cells in which electrical energy is converted to chemical energy are called electrolytic cells, and cells in which chemical energy is converted into electrical energy are called electrochemical cells. Also, I'll be sending you a practice paper for the quiz. You can practice it obviously, and if you want me to keep an additional class to practice that paper, then I can do that as well. But do try to attempt it on your own first. Okay, I'll be sending it right after class.
Okay. When is the quiz gonna take place, by the way?
Does Wednesday work for you?
I have exams the next week,
Oh,
so maybe
oh,
the weekend.
like the coming weekend, tomorrow, or like
Yeah,
the next weekend?
next weekend.
Next weekend. Okay, that works. I think
Okay.
that's around 2nd or 3rd March, if I'm not wrong.
1 second.
We can
Yeah.
have it. We can have it on Friday or Saturday, whatever works better for you. I'm good with both
Okay.
days.
All right. Friday works.
Okay, perfect. 1st March.
Yep.
Okay. So an electrochemical cell is basically two beakers where two different reactions take place. So we're basically comparing two metals. So for example, I have a zinc ion solution here and I have a copper ion solution here. This could be zinc nitrate and this could be copper nitrate. And what is happening here is I have electrodes. Now I'm doing a chemical reaction to generate electricity. How am I going to know that I have generated electricity? I'm keeping a bulb here, or I can keep a voltmeter here to note down the reading, okay? So I have a bulb here, and the next thing I have is a salt bridge. Okay, so in electrochemical cells as well, we have an anode and we have a cathode. The reaction that happens at anode and cathode remains the same for electrolytic as well as electrochemical cells, which is that oxidation always takes place at anode, while reduction always takes place at cathode. This is a set thing which does not change even if you have an electrolytic cell or an electrochemical cell. Electrolytic plus electrochemical cell. So this remains the same. Now, how do we know which one's anode and which one's cathode? For this, we check the reactivity series. So I have the reactivity series here, and if I write all the elements here, and platinum. Okay, so the metals, so the elements that we have here are zinc and copper. So let's see where zinc and copper are. Zinc is here and copper is here. So zinc comes above copper. Zinc is more reactive than copper. So a more reactive metal has a greater tendency to push electrons, and hence that is anode. So basically, the more reactive metal it is, that's your anode. So more reactive metal in this case is
More reactive metal. Wait, it's zinc.
zinc, right? So zinc here will be your anode. Where is zinc? Zinc is on
The left side.
the left side. So this is your anode. This electrode is your anode. And obviously this one turns out to be cathode. So anode has a greater pull of electrons while cathode has a lesser pull of electrons. Electrons travel from the anode to the cathode. So this one, like I mentioned here, more reactive metal has a greater tendency to push electrons. So the more reactive metal here is zinc. Zinc will have a greater tendency to push electrons. So what's going to happen is electrons are going to travel from anode to cathode. So the flow of electrons is going to look like this. And yeah, that's about it for electrochemical cells. One more thing here is the salt bridge. So what happens? Salt bridge will not come in a lot of detail. I will be explaining it to you from an A levels perspective, just in case you want to know what it's for. So salt bridge basically is for charge neutrality. What this means is, I won't go in a lot of depth, but what happens here is when zinc loses electrons and turns to zinc 2 plus ions, zinc 2 plus ions on this side of our cell start to increase. So zinc ions are greater than your nitrate ions, right?
Yeah.
So what happens is NO3 minus, this here has a net positive charge. So this beaker has a net positive charge. However, when we look at cathode, what happens here is copper obviously is going from copper 2 plus to copper metal. So what happens here is the positive part lessens and your nitrate ions increase. Okay. And
Yeah.
O3 minus increases. So there's a net negative charge here. So to maintain the charge neutrality, to remove the positive from here and to remove the negative from here, we use a salt bridge. And what a salt bridge does is this salt bridge has a compound that is chemically inactive. So this could be sodium nitrate or potassium nitrate that is chemically inactive. What this does is, so this part of the beaker was positive, this one was negative. And positive क्यों था? Because we had Zn2 plus ions greater than NO3 minus ions, and here we had copper 2 plus ions lesser than NO3 minus ions, right?
Yeah.
So what happens here is to remove the positive charge here, what happens is either zinc goes into the salt bridge or NO3 minus comes into the salt bridge. And what happens on this side is Cu2 plus, sorry, K plus either enters, K plus or Na plus either enters to neutralize this negative charge, or NO3 minus leaves to reduce the negative charge. So basically, this is for preventing any sort of charge imbalance. Charge imbalance kaise hoga? Because these ions are basically shifting from one place to another. So a charge imbalance takes place, and a salt bridge is to prevent the charge imbalance, or you could say to maintain charge neutrality. Okay, I'll write this
Yeah.
point here. You won't have to explain this in so much of detail, but just in case, salt bridge used to prevent charge imbalance or maintain charge neutrality. So there's that. And let's write the equations as well. So the anode side and the cathode side. Anode pe we have zinc, cathode pe we have copper. So anode is Zn, giving you Zn2 plus and 2 electrons, since zinc is losing 2 electrons to become a zinc ion. Aqueous. Then for cathode, copper 2 plus gaining 2 electrons to become copper metal. And then we make the overall equation. 2 electrons get cut. Cn2 plus 2 electrons, Cu2 plus 2 electrons giving Cu. I'll cut both of these. I'll make an arrow here. Left side comes on the left, right side comes towards the right. So it's Cn plus Cu2 plus, giving you Zn2 plus and Cu. Zn is a solid, Cu2 plus is aqueous, this is also aqueous, it's an ion, and copper is again a solid. So we have our overall equation, and now let's see what's getting oxidized and what's getting reduced. Zinc is going from a 0 to a plus 2. So is it getting oxidized or reduced?
Zinc is it. It's going from 0 to plus.
It's an increase in oxidation state.
Yeah.
Okay,
It's
if you
being
can't
reduced.
remember it this way, just remember zinc is at anode, and anode pair, what takes place?
Oxidation.
Oxidation, right? And oxidation
Yeah.
is always an increase in oxidation number. So 0, say, if we're going to plus 2, we've added 2 to go to plus 2, right?
Yeah.
So in an increase in oxidation state is always oxidation.
Oxidation.
Exactly. And going from 2 plus to 0,
2 plus to 0.
meaning I'm
Reduction.
going back, decrease in oxidation state is reduction.
Reduction.
So here is our redox reaction. Also, for example, this is my reactivity series, right? I have the reactivity series here. And if I say, if I have other two metals, for example, I have calcium and I have aluminium, compared to when I have sodium and silver. So the more the distance between the elements in the reactivity series, the more the voltage generated. So these two have just magnesium in between them, right?
Yeah.
This will have a lesser voltage compared to when I keep sodium and silver together in one electrochemical cell. You get my point?
Yeah.
So if this is my reactivity series, I have this element and this element compared to when I have this element and this element. So this is a greater difference compared to this difference. So the greater the difference, the greater the voltage generated. This will have a lesser voltage, and the red one will have a greater voltage.
Yeah.
If more distance between the metals in reactivity series voltage will increase. Meaning voltage increases, and in the case where you, for example, this will be the case when you have a voltmeter attached, and if in another case you have a bulb attached, so the bulb's brightness increases. Now let's do one more example between two different metals. So I have two beakers again. In one beaker, I have magnesium ions or magnesium nitrate. And in another one, I have gold ions or gold nitrate. These are my electrodes. This is my voltmeter. So in this case, we need to see magnesium and gold in the reactivity series. So the reactivity series goes like this.
Magnesium is reactive.
Yeah, magnesium is more reactive, but I'll still write this just for when you need to revise. E, B, B, C, U, A, G, A, U, that. So there's magnesium, so magnesium here is more reactive, greater push of electrons. And since it's more reactive, this will be anode or cathode?
More reactive, it goes to the anode for oxidation.
Anode. And yes, I'll also write that it's an oxidation reaction. This one, less reactive, lesser push of electrons is the cathode and is doing the reduction process. So this is my anode. This one's my cathode. Electrons flow from
What?
electrons flow from cathode to anode or anode to cathode?
It goes from negative to positive.
Negative to positive. So it's going to go from
Anode to cathode.
exactly. This is your electron flow. Now let's look at the equations. I'll make the solid bridge first, and then we move on to equations. So anode pe we have magnesium, while on cathode we have gold. So magnesium here is getting oxidized. So this should be Mg. Mg2 plus 2 electrons, and cathode should be
Cathode AU, it's gonna be AU, AU2 plus and the arrow, and
3
AU
plus 3 plus arrow.
and the AU, just the element, plus 3 electrons.
Are you sure the arrow will come before?
It's like the wait, what?
So anode may, look, what
It
I
comes
need to say is electrons are going to come here. Will it be 3 plus here or 3 plus after the arrow?
before the arrow.
Before the arrow, right? Because it's a
Yeah.
cathode equation, it's getting reduced.
You do.
So it's Au3 plus 3 electrons, giving you
Just AU.
just Au. So this is aqueous, this is solid, this is aqueous, and this is solid. Now we cancel out, okay, we need to balance this because these are 2 electrons and these are 3 electrons. So what we're going to do is we're going to multiply this equation by
By 3 and the
3
other one
and
by
this
2.
one by 2. So this is going to give us 3 mg, 3 mg2 plus 6 electrons. And this one's going to give us 2 Au3 plus 6 electrons, giving us 2 Au, right?
Yeah.
And we cut out the same number of electrons. This is the left side of the equation. And this is the right side of the equation. So overall equation, I'll make the arrow first. So the yellow part stays on the left side. It's going to be Mg, 3 Mg plus 2 Au3 plus, giving you 3 Mg2 plus and 2 Au, right? State symbols are important. So this is a solid, aqueous, aqueous, solid. This is our overall equation. And we're done with the second example as well. Magnesium, zinc, okay. Iron, copper. Okay, we are done with electrolysis. We are left with half an hour though, and I think we should start with, we can start with group 1. Because it's a
Okay.
shorter topic and we'll get done with it within this class.
First, I just had one question. I was doing
Mm.
past papers. We've done this before. It's for forces of attraction. What's the difference between forces of attraction and intermolecular forces of attraction?
Forces of attraction and intermolecular forces.
Yeah.
So your intermolecular forces, do you have like a question on this? Because they're
Yeah,
both the
okay.
same things as far as I know. Unless like you have a question that can explain me
But
further.
it's like some marking schemes when I'm talking about let's say 1 second. Okay, yeah. So if I'm talking between like diamond and graphite, and I
Hmm.
want to talk about their properties and why they why diamond is hard and why graphite is soft,
Hmm.
etc. So for that they ask us about the covalent bonds for diamond and
Hmm.
the what the forces of the intermolecular forces of attraction for graphite.
Yeah.
So why are we asking for the intermolecular forces for graphite and not for diamond?
I don't get your question. Like, you mean diamond mein why diamond is hard is diamond has a greater number of bonds compared to graphite, right? In
Yeah,
diamond, your one carbon of yours is bonded to 4 other carbons, right?
yeah,
So it has a greater number of bonds, while in graphite, one carbon is bonded to just three other carbons. So there's three bonds. So the greater number of bonds there is, the stronger the structure is. Okay. So if you look at
Yeah.
the melting point here as well, the melting point is 3400 degrees Celsius, and here it is 3700 degrees Celsius, right?
Right.
So there's that. And graphite may, yes, we also discussed that graphite has two types of covalent bondings. Graphite has van der Waals as well as normal covalent bonds. Why does graphite have van der Waals forces of attraction? Because graphite is a structure that is made of sheets. Remember?
Yeah.
So these sheets are placed on top of each other, and these sheets basically give it the lubricating property. Why? Because these sheets have van der Waals forces, which is the weakest force. So basically, these sheets can easily slide past each other, which gives it the lubricating property. What
Okay.
else did we discuss here? Graphite is obviously two-dimensional, diamond is three-dimensional. So all of these differences in between them also give you an edge where you can discuss why one is hard, one is soft, and also their difference in melting points.
Okay.
Yeah, so that's about it. But like, do send me the question so I can properly like look into it and I can
Yeah.
understand what you're actually asking me. Okay.
Okay. Yeah.
So after
Also,
that, yeah, go on.
the only other thing I don't understand how you draw what's it called? Isotopes. I've tried like
Oh,
seven
we
times.
had
I
to keep
never
a
do
class
anything.
on isotopes. Eee. Okay,
Yeah, I was doing it
well,
today and I was like, I should ask Miss this
oops. Are you free on Monday?
Monday.
I can keep
No,
a 1 hour class.
I have a math exam the next day.
Uh, okay, what about Tuesday?
Tuesday, yeah. Free on
Tuesday
Tuesday.
works.
I have
Okay,
the
but
chemistry.
Tuesday I'll probably keep like a very late class because my own classes end at 7 and then I have two other tuition classes, so I'll schedule yours after that, around
Yeah,
9 or 10. Does that work?
yeah, of course. That's
Okay.
okay.
So Tuesday, around 9 or 10, we'll be doing isotopes.
Okay, great.
Okay. So let's start with group one. Let me just open the notes and then we'll start. Oh, also, do you generally want to do isotopes or is it like restricted to one specific um topic? Like, do you want
So,
to do it for carboxylic acids or like do you want to do it as a whole?
carboxylic acids and esters and stuff, that's in paper too. But drawing isotopes, that's the only thing. Because I know the definition. It's like they have the same
Yeah,
structural
you
formula.
just want like practice. I'll take out some questions as well, and then we can do like a collective practice for all the hydrocarbons.
I don't have. Yeah, that works. Because I do not get it. I know how to draw the display formula,
Hmm.
but drawing it in that cyclo, whatever it
Okay,
is,
we'll do that.
okay.
No problem with that. Don't worry about it. So we start with group one. First, we shall do reactivity and electronic configuration. So we've already discussed that in group one, as you go down, the reactivity increases, right?
Yeah,
So I'll write this as pointers. This is a very boring topic, by the way.
yeah,
Going down in group one, reactivity increases. When a group one element reacts, its atoms only need to lose electrons. So group ones are all metals, and metals always lose electrons. Metals lose electrons, which is why metals make cations. For example, if I talk about sodium, which is in group 1, it's going to lose electrons and turn to a cation, that is Na plus. Because metals ke liye, it's much easier to lose electrons. Why? Because, for example, if I have sodium here, this is my sodium atom. And I have one electron here, right? Wait, 1, 2, 3, 4, 5, 6. Yeah, one electron in the last shell, right? So is it we are using the octet rule, and that is to have the last shell filled with all 8 electrons, right? So what's
Yeah,
easier for it, to get 7 electrons inside or give 1 electron outside? What's easier? What would
give
you
one
have done if you were an atom?
give one electron.
Given 1 electron, right? Because taking 7 is too much. So metals always prefer giving 1 electron, and hence we say that metals donate electrons to make cations. Non-metals always get electrons, accept electrons to make anions. Okay?
Yeah,
Only need to lose 1 electron in the outer shell. In the outer shell. And when this happens, +1 ions are formed. The next shell, meaning after this loses the electron, this shell gets removed, right? So the next shell, what we mean by the next shell is this last shell. So this becomes the valence shell when this shell leaves. So the next shell down automatically becomes the outermost shell. And since it's already full, a group 1 ion obtains a noble gas configuration. Noble gases always have 8 electrons in their outermost shell, right?
yeah,
So all the elements are basically striving to get a noble gas configuration. Elements turn to ions to get a noble gas configuration. Na
yeah,
plus, sorry, Na goes to Na plus, loses 1 electron, so it has 8 electrons in its outermost shell to get a noble gas configuration. Next thing we have here is, as you go down group 1, the number of shells of electrons increases by 1. Uh, So going down increases the number of shells, and going left to right increases number of electrons in the last shell, right? In the
Yeah.
last shell. So as you go down, the number of shells is going to increase, but the last electron in every atom, but the last shell in every atom will have one electron. So the first element here will look something like this. Two shells with one electron in the last shell, and the last one might have three shells with one electron in the last shell. So the number of shells keeps on increasing, but this point remains constant, which is that the last shell will always have one electron. So group 1 atoms always make ions that have a +1 charge. So they always lose one electron only.
Yeah. Okay.
This means that the outermost electron gets further away from the nucleus. So there are weaker forces of attraction between the outermost electron and the nucleus. Hence, less energy is required to overcome the force of attraction as it gets weaker. Hence, the outer electron is lost more easily as you keep going down. So the outer electron keeps going further and further away from the nucleus. If I zoom in here, we see that the distance between the nucleus and the outermost electron keeps increasing as you go down. So it keeps moving further away, which makes the force of attraction weaker. So as you go down, the last electron keeps getting easier and easier to get removed from the atom. It gets weaker, hence the outer electron is lost more easily. So the alkali metals, meaning group 1, get more reactive as you descend the group. Okay, so this is basically the explanation for why reactivity increases down the group. So if they ask you this in the exam, these are the 3 pointers that you need to write.
Okay.
And we have, so this is basically filled with notes only. Following these trends, rubidium, cesium, and francium will react even more rigorously with air and water than the first three alkali metals? What are the first three alkali metals? It's lithium, sodium, potassium, right? And after all of these, like these come very late in group one, but they are part of group one.
Yeah.
So lithium is the least reactive since it's on the top, and francium, since it's at the bottom, is the most reactive. Then we have, these are some properties of rubidium. Soft gray solid, appears shiny when freshly cut, more dense than potassium, meaning its density is greater than 0.86 grams per centimeters cube, has a lower melting point than potassium, meaning lesser than 63.5 degrees Celsius. No need to learn all of these numbers, just for an idea. Then we come to physical trends. Alkali metals are soft, easy to cut, getting softer as you go down. The group first three alkali metals are less dense than water. Hello?
Yes, ma'am.
5 more minutes. क्यों क्या हुआ? हाँ, इतना इम्पोर्टेंट नहीं है. ओके, आप कहाँ जा रही है? हम्म. नहीं, मैंने जिमिल से कह दिया था वो ले आएगी. हम्म. नहीं, मैंने जिमिल से कह दिया था. ओके. Okay, first three alkali metals are less dense than water. Then the last physical trend is they all have relatively low melting points. Low melting points, which decrease. This is an important point as you move down the group. Due to decreasing attractive forces, as we just discussed, between outer electrons and positive ions. So here I'm going to make a graph that compares the melting point of these metals On the y-axis, we have melting points in degrees Celsius. And on the x-axis, we have our metals. So here we have lithium, and we have sodium, potassium, rubidium, cesium. So lithium comes at 180. Sodium comes at 100. Potassium comes at 60. Rubidium comes at 40. And cesium is somewhere between 40 and 20. So this is here. Okay. So we see here that the melting point decreases as you go down. Then we have reactions with oxygen. One last heading before I end class. They form metal oxides. And this is why they tarnish when exposed to air, because they start reacting with the oxygen in the air. Second point here is metal oxide produced is a dull coating which covers the surface of the metal. Metals tarnish more rapidly as you go down the group. Why do they tarnish more rapidly? Because we just discussed that going down the group, the reactivity increases. Metals tarnish more rapidly as you go down the group. So I'm going to make a little table here. Here we have the element, and here we have the reaction. These are basically like a revision from the acid basis salt chapter. So we have lithium reacting with oxygen. This gives us lithium oxide. And the equation goes lithium, which is a solid, reacts with O2, that is a gas, giving us Li2. Oh, now to balance it, what we're going to do is we have two oxygens here, we have two lithiums here. So you put a 2 here. Wait, we have two oxygens now here. To balance these two oxygens, I'm gonna put a 2 here, right?
Yeah. And then you have 4 lithium, so 4
Exactly.
Ni.
So I'm gonna put a 4 here. Then we have sodium. Sodium plus oxygen gives you sodium oxide. And the equation is sodium plus oxygen. Sodium is a solid, oxygen is a gas. This gives you Na2O. So again, to balance O2, I'll put a 2 here, and to balance these 4 sodiums, I'm going to put a 4 at the back of sodium. The last metal that we're going to talk about is potassium. So potassium plus oxygen gives you potassium oxide. And the equation is potassium, which is a solid, plus oxygen, that is gas, gives us potassium oxide. To balance. Okay, it's already balanced because we have two oxygens and two oxygens here, one potassium and one potassium here. So all of these are oxides, and these oxides are in their solid forms. Okay, we are done till here. Next class, we're going to be continuing with reactions with water, and we might even start off with air, except for the class that we need to do isotopes. So isotopes wali class is scheduled for Tuesday, right?
Yeah.
Okay. So I'll see you on Tuesday, and I'm gonna send you the practice paper right now. Make sure you attempt it, and if there are any questions that you don't understand, the Tuesday's class we can do isotopes as well as the practice paper. Okay. The practice paper includes the mark scheme, so you can refer to it if there are any sort of questions that you have. Okay.
Okay, miss.
Okay.
Great.
I'll see you on Tuesday. Take care.
Bye, miss.
Bye.
Wait, miss, don't we have a class tomorrow?
Oh, wait. We don't have a class tomorrow. I will be traveling tomorrow.
Okay.
So
Yeah.
no class tomorrow. Thank you for reminding me. I should have told you earlier.
Yeah, I was like, okay. No, that's fine. I have more time to do math than math is my downfall. So,
Okay, that's great. But I will be keeping a makeup class for it, okay?
okay.
Maybe
Miss,
a 2 hour
also,
class or something. Yeah, go on.
yeah, after this, this is my mocks, right? After this, I'm gonna have my IGCSE
Hmm.
straight. So, is there you've done your IGCSE?
Yeah.
Is the mock easier or is the actual exam easier?
It honestly depends on your school. My school used to make really hard mocks. So like if you've cleared the mock, you're able to go for your IGCSE. Because my school used to make the worst papers. They were like the difficulty level of IGCSE is into 5. So they used to be really
Oh,
bad. Yeah, so our teachers used to tell us like, if you've passed the school paper, then you're good to go for the IGCSE. So if you get a B in your school paper, you'll probably end up getting an A star in IGCSE. So that's how our school papers were. But I would suggest like our teachers used to tell us to do the past 10 papers ke past papers. Sorry, past 10 years ke past papers. So we used to do 10 years ke past papers, all variants and all months.
what? I only did the
Yeah.
new specifications. Oh my
No,
God.
you should do the older ones as well. But don't like if obviously some of the questions are obviously repeated. Like once you start doing them very religiously, you're probably going to realize ये question तो वापस repeat हो रहा है, right? So you probably won't be doing that question again. So that saves a lot of time, and you should now focus only on your past papers, because if you keep doing past papers, for example, you can't recall a definition, you're going to open your notebook for that, right? So all of that
Yeah.
just keeps getting like it becomes part of your immediate recall that way.
Yeah.
So just go through the theory once, start with past papers, and if you get stuck on a question, open your notebook there and then and solve that query there and then. Don't leave it for later. Solve it and make it a point to go back to that point where you got stuck before your actual exam.
Okay.
So that's what helps. And like keep like a notebook with you where you can put in like key points के end में ये revise करना है. Keep all the definitions together that you need to know because all one markers are definitions, two markers where people easily end up losing a lot of marks.
Right. Yeah.
Right? So do that. And yeah, that's about it. Don't worry a lot. O-level
Wow.
chemistry is easy. Don't worry.
Okay. Cool.
Just focus
Because
on
I've
past
just been
papers.
doing like the new spec, so that's still like 2019 to
Hmm.
2022.
Yeah, that's fine. Do you
Because
have
like
2023 papers yet?
no, they're still logged. And our teacher for psychology, they got the 2023 past paper, and I was so sure they were gonna get the past papers I did and our marks. And then
Yeah,
I was
that's exactly what
accepted.
happens because the school get the papers earlier. Yeah, the
Yeah.
same thing used to happen with us. But that's great, because even though you don't have access to them, the mocks give you access to those papers.
Yeah.
So
Let's just hope my exams go well this term, especially math. I know chemistry, I'm good with chemistry, bio, but math, I'm telling you, math is my downfall.
math
It's
is so
everyone.
much fun. I love
Don't
math.
don't lie to yourself, miss. Come on. That is,
Do you have
miss, I'm
add
not,
math?
do I have what?
Add math, additional mathematics. That's another subject.
No, if I took additional mathematics, miss, I would cry myself to sleep every day. That is no, miss. I'm not even taking it for A levels. I already told my parents
Really?
I cannot do. I can't. I
You
actually
should
can't.
take math for A levels. You'll
Miss,
have
no way.
more. What do you plan to do in the future though?
Clinical psychology.
Oh, okay. Then you don't need math.
Yeah. If
I
I took
agree.
miss, honestly, I'm telling you, math, I cried myself for a week straight because I couldn't do a problem. Yeah. And you said
You know
math is
that
fun.
now you have ChatGPT. Like even when I can't solve anything, I just copy paste the whole question there, and you get like a proper a proper solution for it. ChatGPT basically like starts explaining you everything from scratch.
Yeah, I tried
It's
asking it the question.
basically like an
And
online teacher. Not gonna lie, like
bro, I asked like my chat GPT and it gave me like functions that I didn't even know existed. Like,
yeah.
okay, I guess.
Sometimes it's very complicated, but like you need to pick out things that you want, right?
Yeah.
So there's
Just
that.
hoping. Just hoping I get a 7 or 8 and I'll be happy.
You
If
will,
I
you
get
will get really good marks. Don't worry about it.
let's hope.
You will, don't worry. Okay, after class,
You're gonna
you're
send the
going to
paper to
send me,
me.
yeah, I'm gonna send you the paper and you're gonna send me the graphite wala question. Okay?
Yes, I have to like search them up because I did like I have 3 past papers left. After this, I'm going to bio and then no. Yeah, bio and psychology. Today's my good day.
Oh.
So
Okay. Tomorrow is also a good day. I'm not taking a class.
see, I like your classes. So like,
Oh, you're so
yeah.
cute.
Miss,
All
what?
right.
You're in UK, right? For college?
No,
I wait, what?
no, I'm in Pakistan.
Because your number is a British number.
Yeah, that's because I have a separate business account for my tuitions.
Oh,
Yeah. My
that's
sister's in
fun.
the UK though. My twin sister studies in the UK.
You have a twin. Oh my God,
Yeah.
is it like an identical twin?
No,
Oh, okay, that's good. We learned about that. I mean, you
really?
know, yeah, we were learning about depression and addiction. So there's a higher chance that you would develop depression if your twin had depression, like a
Whoa.
52% chance. Yeah, it's
Mm.
crazy.
You're from Abu Dhabi, right?
Yeah, I was born and brought up here.
Oh. Oh, my
Yeah.
sister. Okay, so basically my twin sister studies in NYU Abu Dhabi and she's for gone for an exchange semester to the UK for this semester. So basically she lives in Abu Dhabi, but she's there
Oh,
for like 5 to 6 months in the UK.
you you both took business as your major?
Yeah. And
Slay.
we both studied sciences till A levels, sadly.
Bro, I don't even know if I'm gonna take 2 or 1 science because the horror stories I have gotten, uh, they got me shaking, bro.
Don't worry, you will be fine.
Let's hope, I really want to get into uni. So
You will. Like, Who doesn't?
And
You will. You're so smart. Don't worry.
let's hope. Anyways, I'll get out of your shoes now. I'll see you on Tuesday.
Okay.
Bye, miss.
Bye bye.